Hi everyone. Hi. Very warm welcome to CoderDojo Ham's November live stream session. I'm here with Lena and Danny, who are going to start the Scratch game, a hilarious Santa seasonal game. And Richard there's joining us in the studio for the broadcast. And he'll be joined by Ozzy later on for the exciting adventure into machine learning. And then in 50 minutes time, we've got Louis helping or leading a session to show you how you can use Python to crack your maths homework. So that's going to be hugely useful and interesting. Now, if you're watching, you may be watching either on Twitch TV or on YouTube, it doesn't matter which, but if you want to get help during the session and post your code or links to code, then you need to be on Twitch TV. So anyway, let me hand over now to Lena and Danny for the Santa game in Scratch.
Hello.
Hello, I'm Lena.
And I'm Danny.
And today I'm going to show you how to make my Santa launcher game.
All right, can we see a demo?
All right. So...
Okay, so we've got a rather cute Santa. And what's happening? He's following the mouse. What happens when you click the mouse?
He gets launched. And
so you got to launch Santa into the chimney. You're rather good at that. Cool. Okay. So we're going to try and make it.
yeah, let's try and make it.
Okay.
So firstly, yeah, let's go. So we've got an asset pack for this. It has only got the sprites and the art. So the only thing we need to do is, well, we're going to remix it so we can make it. Basically, we're making a copy.
So we're going to remix the asset pack so then people can build their code upon the sprites and sounds that are already there?
Yes.
Cool.
So let's just press the remix button. And yeah, so now we've got the asset pack. Let's do the code. So first let's get Santa on the screen and moving around.
Cool.
So we also want to position Santa so then he doesn't just start wherever he wants, because you might accidentally win.
Show us the code.
So
okay, so when that's clicked and you put in that position, he's already going to be in this position because the asset pack's kind of placed in there, right? So if you just drag that on, it'll be in the right place. Excellent.
So we also want Santa to show.
Right, because we might be hiding him later, so we don't want him to be hidden. Yeah.
And we also want him to point in the right direction.
So he's facing the right way. Okay, cool.
So, yeah, so now we're going to make Santa follow the mouse, basically. Point towards the mouse.
Oh, okay. Excellent.
So we're dragging a repeat until.
Yeah.
And then we want mouse
repeat
down.
Until mouse down. So that is in the sensing block, mouse down. Okay, so that means that loop will repeat until you click the mouse.
Yes.
Nice.
So it will not go to, but point towards mouse pointer.
Okay, can we see what that's going to do then?
Yep. So it's in the right position.
So Santa is now facing the mouse. So you can then perhaps, there's a good point to save and test your code.
And when you click, it
just stops because we haven't got any more code.
So it's a good time to save. And yeah.
Nice.
Now to launch him.
Oh yeah.
This is going to be fun. So we're going to use custom blocks, which are basically functions in Scratch.
Okay.
So we're going to create our own block.
Yeah.
So add nothing here. And I'm going to name it Launch Santa.
Okay, so we're making a Launch Santa custom block. Excellent. Okay.
So we've got this defined.
This is what's going to happen when we click the mouse. Sweet.
Yes.
Okay. What's the first thing it's going to do?
So we can add a little bit of sound, which is fun.
Notice that's just start sound, not start until done. Otherwise
Yes.
he'll pause.
You won't do it.
Okay.
So we want a low whoosh sound.
Cool.
And now we're going to create two variables.
Okay.
X speed, and Y speed.
So I think we're about to do something sneaky with physics. So we need to actually track the X speed and the Y speed of Santa so we can actually make him fall. Cool.
Yes.
Okay.
So we want to make them hide because we don't want them in the front of the screen. That would be annoying.
Yeah.
So we've hidden them now by pressing these tick boxes. And yeah, I'm going to now do some, we're going to set them. And I'm just going to, yeah.
So we'll set the X speed.
And yeah, so we're going to use this multiplication in operators.
In operators, yeah.
And we can drag this in. And we're going to be using sine and cosine for this.
Okay, and what that will do...
To create a separate X and Y speed for the direction that we clicked.
So that will turn our... So if you carry on building the code, it'll turn the direction we're moving in into some speed, so into some sizes of X and Y. So we can then manipulate those speeds, basically. Yes.
So my suggestion is that it would be sin of direction 6.
Okay, so kind of okay, fair enough. So he's going at a speed of 6 upwards, or 6 times that, right?
Yes. So I'm gonna just duplicate this duplicate it across, and change it to Y speed. And this is not going to be sin; it's going to be cosine.
Cosine, okay.
And instead of 6, I think 7, because we don't want him to go too low on the Y position.
So we're kind of making it a slightly
ellipse.
Yeah, an ellipse curve. Okay. When you talk about sin and cos, you're talking about directions and curves. Okay, cool. What do we do next then? So that position.
Now we're going to drag in a forever and do some go-toing, if that makes sense.
Okay.
Yeah, we're gonna add some some addition, and if you understand, X position plus X speed.
So we're going to set the position to the old position plus the speed.
Yes.
Okay, cool.
And I'm just going to duplicate this, and it will be Y position plus Y speed, which makes sense.
Oh.
Y speed. So.
Okay.
Yeah.
So okay, can we test this?
No, we can't, because we haven't called the function yet.
Ah, okay. Oh, there's a bit more on this function, actually.
Yeah, there is.
Ah, okay, we haven't got gravity.
Yeah, so we're going to drag this here, so then we can actually call the function. And once it's done, it will work.
Okay, cool.
So we can do change. We also want to change the Y speed, so then it goes and does gravity, basically. It starts falling.
Starts falling, yeah.
So we want this to be minus 0.1.
Ah, okay.
And also, just for a little more fun, we don't want Santa to just go in the same direction all the way down. So let's turn him by 1 degree.
So he tips over while he goes.
Yeah.
Okay.
So now this is testable, so we can save this.
Well, let's demo it then. Go on in. So if you've got questions, please do leave them in the chat and let us know if you've managed to get where we've got. If you've managed to find the project and make this work.
So.
Okay, so we've got Santa launching.
And.
So what's next?
Yeah, so next let's go to some scenery, since we've got Santa working.
Cool.
And so the scenery is the ground sprites, these 4 sprites, and we want them to stay where it's positioned and make sure that we can see it.
Okay, so make sure they're not hidden and make sure they're in the same place. Cool.
Yes. So we'll drag in another when clicked.
Yeah. And
since it's already been filled in for us, we don't really need to fill these in.
If you drop it in, they'll be in the right place from there. It just means if they get dragged off, they end up back in the right place. Cool.
So we can make this show. And this is the same for the snow sprite, but the chimney sprites and the chimney top sprite, they need just a tiny bit different. So this will be 200.
200 minus 140. Because the chimney's in a different position from the rest of the ground. Okay, got you.
Yeah.
And that's the same for the chimney top.
So we can just duplicate this in.
Okay, so this doesn't look like it's going to do a lot yet. It's just going to make sure we still see what we're going to see after we start doing some more interesting stuff. Cool.
So,
and now is another good time to save and to test your code. So again, if you've got any questions, if there's any problems, put them in chat. We are watching chat, so let us know if we need to slow down and go back to anything.
Yes.
Right, what's next then, Lena?
So we've got scenery now.
Yeah.
But we also have a few animations down here. So, yeah, maybe we can try and make those work. So, firstly, we need to choose an animation based on where Santa hits.
Ah, cool. So he's going to hit something and things happen. Yeah.
If we go back to the Santa sprite over here,
we
need to make another variable, and this one's going to be called animation. So this will control what animation is being used. We also want to hide that because we don't want that to show.
Yeah.
And now let's add a bit more code, basically.
Okay, so we're going to sort out what happens with animation. So we've got another when flag clicked. Cool.
And we also want to set the animation to 0, so then it doesn't accidentally go to the win.
Trigger anything to start. Okay, cool.
And let's add a forever loop.
Yeah.
And we're going to put an if else. And the reason is that you want it to touch the chimney top more often than it touches the other one, probably.
So we're giving the player the benefit of the doubt on the chimney top and chimney side. Okay.
If you're me, you don't have to do this.
This might make more sense if we've got a bit more of that code in. So if you've got, so that's how that looks.
So we can chimney top. The reason we got chimney and chimney top is because if you just hit the side of the chimney, then I don't think that would count.
So you want to make sure they've kind of hit the top of the chimney, or at least caught the top of the chimney. Okay, cool.
Yeah.
Yeah.
And now we want to set the animation to win, because win. Yeah. So
win conditions hitting the chimney top.
Yep.
Okay.
And now we want to create a new broadcast message, and this will be called Santa Hit.
So to let the rest of the game know that Santa's hit something, and now we've got to take some kind of action on it.
Yep.
Cool. Okay. Yeah.
So there it is. And that's it for this if. But now we need to create all the others.
All
so
the other conditions.
If you hit any of these 3. So we'll do if then and touching. To start with, I think we should start with the chimney.
Okay.
So I think we should just copy this.
So you can duplicate that code there and just change the settings. That makes sense, yeah?
Yep.
Just change animation name.
Maximum efficiency. And this will be chimney slam. You can call it whatever you want as long as you know what it is.
As long as it matches front there and back, but I guess we can use the suggested names for now.
I'm going to use chimney slam. So if we just copy this, if we copy this,
duplicate the chimney, okay, and you can
and put it underneath, then we can do the snow, and I think this can be called fell in snow. Why not?
Fell in snow, yeah.
And fell in the snow. And now we can do the ground. So floor slam.
If we manage to actually completely face plant him on the ground. Got you. Poor Santa.
If you accidentally go up here and then down straight here instead of hitting anything
Awesome.
else.
So we're broadcasting some messages. What's the first message we're going to want there then?
So we want Santa to not just stay showing during this when he hits something. So we want to do a when I receive message Santa hit.
Yeah.
We also want him to hide, and we also want him to stop.
So we want him to stop moving and to hide.
So
Yeah.
stops all the other scripts in the sprite and hides.
Cool.
So testing this it's a good time to test and save. So I'm just gonna very quickly do so. And I'm just gonna show the animation. Don't do it yourself. I'm just gonna show it to make sure it works.
Oh, just see him stop. Well, you could test that and see he stops, and that would be a good time to save.
Yep.
Yeah.
So the animation is win.
So we got the win animation.
Yep.
So again, if you've got any problems, let us know. If you appear to have any, if you've got any comments, please leave them in the chat, and we'll try and cover any things that anyone seems to be stuck on.
So we can test these on all of these. So phone snow, that seems correct. So it works.
Cool.
And now we're going to.
Oh, we're going to go to the win sprite, are we now?
Yes. So
the
then
win animation. Okay.
Oh yeah, and there's probably another thing we want to do. So when we do our animations, we probably want to hide all the background, the scenery sprites.
Oh, we need to do that first. Okay.
So if we just drag and copy all of this code into all 4 of these, we can test if this works just after. So let's test if it works.
Oh, so all the scenery disappears when you hit something.
I'm just going to hide
Okay, and so what Helena did is she just copied that code. She's got her mouse pointer over into the ground, snow, chimney, and chimney top sprites. So there's a lot of duplication going on there. Excellent. Saving a bit of time, I suppose. Okay. And what was next then?
So next up, we're going to work on the wind sprite. So
get the windscreen going. Nice.
Yes.
Okay, so making sure it stays in the same position just in case you accidentally drag it off.
Yep.
And hiding it. Okay, so it starts hidden because obviously we don't want to show the windscreen at the beginning of the game.
Because we don't want someone to win immediately. That would, yeah.
They got to do stuff to win. Just to say, where it references sounds, this asset pack has already got sounds included. If you want to replace those sounds, all the sprites, feel free to replace the sounds and sprites. We just picked what we thought was funny. And some of those funny sounds which you'll hear are ones that I made myself.
Yep, like the voice sounds.
We'll see those. Go on, Em. What do we do after this?
When we receive Santa hit,
yeah,
we want to know if the animation is win. So if animation equals win, make sure it's the same caps.
So that has to be spelled the same. And it's got to be spelled the same as the chunk of code in the Santa block. Can you show us that chunk? So
where it says win,
that has to be the same name as you've got in the win sprite. Okay.
It's cap sensitive.
It's case sensitive.
Case sensitive.
So it's got to be spelled exactly the same way.
Yes. So all we really want is to show this and maybe even play a bit of sound.
Play a win jingle.
Win.
A jingle.
Sound win.
And so do we want to stop everything? Oh.
We can test this.
Okay, cool.
We don't need to. It stops on its own.
Yeah. Got
you. And we can test this if I can get it.
And what happens if you hit something else? Just make sure he doesn't.
Nothing.
Okay, nothing. So we've got almost a playable game there, right? So there's a really good time to stop and save your game and to test. And now's also a great time to say if there are any problems at all. So if there's anything you find too difficult to do or find you're stuck on, then post it to chat, let us know, and we'll see if we can cover some stuff again. Cool. So now we've got the main game. I think you wanted to jazz things up a bit. Yes,
so I put some animations into this, and...
Oh, yeah. Some animations.
So we can do those later, but right now I think it would be nice to add a bit of Christmassy jazz.
Christmas music and some jazz. Okay, cool. So what have we got?
I've already put in some Christmas sleigh bells and just some music.
Okay, and we're going to get those going throughout the game to give it that really nice Christmassy feeling. Okay, go for it.
So when clicked, forever, and we can do play.
Play sound. The sound's called DoraDo. We'll see why in a minute. And notice that's a play until done here.
Because if you play start sound, then it will just play it again every, it will play the first second and then it will start again. So it's not a very good thing.
You get this horrible sound overlay, which we don't want. You want each of the sounds to be nice and, to play and then finish. Okay, cool.
Yeah. So I think from maximum efficiency, we can just duplicate this.
Okay.
And change the sound inside. It's really not that different.
So we have sleigh bells and other sound going together. Cool.
So do we want to have a...
Yeah, let's see what that sounds like. And that's already more Christmassy. Sleigh bells and music. Love it.
Yep. So I think that's really cool. So we got a little bit more.
Right.
A little bit more for the music. And I just thought this would be fun. This is definitely not needed. This is just for a little bit of fun.
Okay.
So I think it would be funny to make Santa say ho 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 every few seconds. That would be funny.
Okay, cool. We're gonna do that randomly?
Yeah.
Okay, cool. Let's do that then.
Sounds good. So forever.
So we've got another forever loop, yeah.
And don't forget to make sure it says until done at the end.
Because you don't want them overlaying.
Yeah.
Oh yeah, that would sound weird.
So, and then we can wait for pick a random seconds. So if we go to the operators
in
now.
Operators, green, we've got pick random, yeah.
So we can drag the 10. Now it says 1 to 10.
Okay.
And I think 10 to 20 sounds good.
10 to 20, yep, okay.
So it will only play it
every 10 to 20 seconds. And it'll play it the first time. We're doing a forever loop. Yeah, okay.
Yep.
We can see what that sounds like.
We can test this. Also, this is a good time to test and save.
Again, yeah. Always make time to test and to save. Okay, go for it. Yeah, I did that. Lovely sound effects provided by me. And does the rest of the game still work?
Yep.
Yay. Okay.
So that's the game so far.
Cool.
And now I'm going to do a bit on the animations, like I said before. And
game over animations.
Game over.
Sweet. Okay.
They're pretty funny too, and they have some sound effects, again, made by my dad.
Okay, so in the events panel.
In the events panel, we just want to drag in another one clicked.
Okay.
And we wanted to go to the same position, and we also wanted to hide.
So we're going to go to the start position 0, 0, and we're going to hide it. Okay, so this is in case, again, someone drags off the sprite. You just want to make sure it's the same place. And you want to start hidden, because we don't want to be showing game out of animations at the beginning of the game. Bear in mind, if they're going to get turned on, we're going to make sure they're turned off for the next game. Okay, that makes sense. Yeah.
So another thing is, we also wanted to go to the first costume.
Can I have a look at the costumes in this?
Yeah.
So in this animation, there are basically a ton of frames of separate costumes. So obviously every time we play it, we've got to reset back to costume 0 before we change costumes. So the animation is, I suppose it's kind of been animated manually by yourself, or
yeah.
Okay. But so what we're going to do is just basically flip book through these costumes when it's time to play the animation.
Yeah. So we wanted to start at the first costume, so then it doesn't look weird.
Yep. Okay.
So they're all called costume 1. So if you just drag and drop this into...
So you're duplicating that and dragging that over animation 1, 2, and 3.
1, 2, and 3.
Yeah.
So there are 3 ways to die.
Nice.
Beautiful. So now we want to do a little bit different code for all of them, because they all have different amounts of frames, and we don't want them to play to half play. You
want them all to play all the way through, and they've got some different sounds and things going on as well.
So they have their own custom, I don't know how to explain.
Well, let's start making some code, and then I'll try and explain it while you go.
So when I receive Santa Hit,
which is in the events tab, okay, and Santa Hit, that's the event that we got Santa to broadcast when he hits something. Yep, cool.
And we also want if animation equals, this one is the chimney slam. So if animation equals chimney slam.
Oh, so you need equals from the operator. Got you.
And animation from variables.
Got you, yeah. And that, again, you need to make sure it's the same words and capitalization that you used for that chimney hit inside the Santa sprite.
Yes.
Yeah. So this is a lot like the win animation. It's a very similar, I suppose it's very similar. Oh, the win is just a screen, not an animation, right?
Yeah.
But it's similar for how we start this off. Okay, cool.
So we also wanted to show, because it's
in looks tab, we've got the show button. Yep.
Down here.
You can see it. Yeah.
And we also want it to wait just a second so you can get to see the front page
before it starts animating, so you kind of get a lead in. Okay. Yeah.
Otherwise, it's just too quick.
Understood.
So we also want a repeat, and this will be 14 times.
Okay, so it's going to go through the animations. Got you.
But not fully, because we also wanted to play some music in between.
Oh, okay.
Some animations.
You have to show me this. This is quite sneaky.
So start sound, not oof, but I think clang.
Okay.
And then start sound again.
Yeah.
Pick random 2 to 4. So the reason that it's 2 to 4, the reason that it's 2 to 4 is because these have a few different
sounds.
Sounds.
A few different oof sounds and a one clang sound. I see. So you're going to play those together, but you want it to randomize the oof sound it chooses. So you get a slightly different oof sound each time. That's fun.
It's going to be funny, but this is one of the hardest animations to get.
Okay.
So we also want it to continue the animation after it does.
So it's only partially animated before making the noise. So is that the frame where he would? So I think this is the chimney slam. So this is a frame where he actually makes contact with the chimney.
Yeah.
Is that what that is? Okay, so you get the clang and the oof at that time. That's cool.
So it's quite cool. Oh, I'll just do this for a second.
Yeah, just hang there and save the project. So we can save the project, and now's another good time to test. This would be funny. I don't know if you're going to be able to hit this. It's the hardest bit to test, is it?
Yeah, it's the hardest one to hit.
You've got to try and hit the side of the chimney, which is actually
pretty
hard to do, but it's kind of funny. See if you can. No, you hit the snow. You have to go up a bit.
And just I either win or lose another way.
It's quite hard to hit the side of the chimney, but it does happen. I've seen it happen. Okay, cool.
So we want to do something a bit similar, but still different. So
for the falling in snow. Okay.
Yep.
Are we going to be able to duplicate the original code and mess with it? Or
I guess we could. So it's pretty similar, but also different.
Okay.
So here we got our Santa.
Here we're going to do.
Yep.
Oh.
Sorry.
Yeah. So that cleanup blocks. What Helena did there was right-click and clean up blocks. When you drag blocks into another sprite, it seems to bunch them all up in the same place. So if you show that again, right-click. Oh, so it's like that, and you right-click, clean up blocks, and it just puts them in a sensible place, so they're not all on top of each other. Handy. Yeah. So cool. We need to change this to fell in snow. And again, that needs to match whatever text is used for the falling in snow check inside Santa.
Yeah.
Santa sprite. Okay.
So, firstly, this has only 18 sprite.
18 frames.
Frames, yeah. And we don't need this. This is kind of different.
Okay.
Instead of play sound clang, we want to do play sound muffled. Not muffled. Plunge until done, and we want this to be play sound muffled.
Oh, so it's got a different sound effect for when he lands in the snow. Okay.
So let's test that again, because it's pretty funny.
Yeah.
Oh. Bit of lag there, but it worked.
Okay. So we've got a noise of him hitting the snow and mumbling in the snow. Wonderful.
So animation 3 is more similar to animation 2. So this is going to be pretty easy. Also, we want to clean up this too, because...
So clean up the sprites again, just so they're not all on top of each other. So again, I just remind anyone following along please let us know in the chat. Tell us if you have got it working. Tell us if you have got Santa to fall into things and you got some of the funny sound effects going on. And tell us if you've also replaced some of the sounds or sprites with your own. Definitely love to see what you come up with.
Yeah.
Okay, so we're now doing the last animation.
The last one is pretty much the same as the one we just did. So this is floor slam or whatever you called it.
Hitting the floor, okay, floor slam. Yeah.
And this only has 11 frames.
Right.
And I think so we're gonna play Hard Oof, which
Hard Oof
sounds like this.
Right.
So you kind of get the idea. Now,
so if we try the floor hit, then
it's pretty easy.
Okay.
Also, this is kind of the animations are themed on Among Us. Clearly.
Right, that's kind of funny. So, I mean, that's kind of most of the game. Let's see if we can go back through some things. I'll tell you what would be good. Be good to see if you could still try and demo the side of the chimney, because I don't think anyone's actually seen you do that.
No, let's.
We might have made a part of the game that's too hard to demo here.
Yeah, let's
go. But if you hit the side of the chimney. I wonder if you can drag the chimney top across just 2 pixels. Oh, we need to clean those blocks up. So if you make the X go across 2 pixels, so he's more likely to hit the side a little bit when he catches it side on. And that way, he's more likely to hit. So if he hits the corner, it doesn't count. It's a hit the corner as opposed to if he hits the top. Let's see. Hopefully this doesn't make it too hard to play.
That's pretty easy. Hey. There we go.
There's the hitting the Santa on the side.
I'm just going to change that back for now.
You like it easier, huh? That's all good.
No. It's just because the chimney top, it goes kind of off the...
So perhaps for a little recap, possibly the bits we wanted to go and just make sure people were kind of clear on, go back to the Santa sprite, because that's where the complex stuff is happening. And it's this launch Santa part here, where we've got him launching using, was it the sine and cosine of the direction? So
just to recap where we find sine and cosine.
Yeah.
It's this bottom block on operators, and it's abs of, but it has a lot of stuff. So
you can choose which of those math functions you use. And sine and cosine, when given a direction, give you back a number you can multiply something by to get things to go in a particular direction. And that's so we can change this Y speed. Because I know, Scratch, you've got the idea of being able to move in a direction, but we're adjusting this Y speed, which gives us that bit of gravity.
Yeah, so it goes into an ellipse shape.
Because it starts going upwards, well, presuming you've shot upwards, and then it starts falling off fairly quickly. So that little minus 0.1 is our gravity factor. And you could even have some fun with this, and you could actually make that number smaller, like 0.05, and start to put in moon gravity, or you can even do Jupiter's gravity and give it a really high number. I think that might be unplayable. But you can certainly tweak the gravity factor.
Yeah.
And the other thing you found, because I think you found a way that you could kind of change how easy or hard the game was.
By using these two numbers, so where it says sine or cosine times 6, you can change that to a higher or lower number if you want to change the difficulty.
So it just means you might have to aim a little bit higher. It's one of those factors we can play with. So that's how the gravity part of it works, and the ellipse and the curve.
So another thing we're gonna do embellishments on is new levels. This definitely can do more levels.
Oh, so you could add other levels with other things and maybe make it so, I don't know, Santa's scaled down and there's more obstacles to cross or something.
Yeah, so I definitely suggest that if you want to.
Before we kind of carry on with embellishments, can we have a closer look at where we're choosing the animations?
It's a
So-
little bit big on the screen, so I'll just do this. Hopefully that's okay.
So this is where we check in a forever loop.
Yep.
If what we're touching, you can't make the loose. Can I make the loose scene anything? You can make the loose scene anything.
Go
Why not?
for it. You can do whatever you want.
You can make the loose scene something fun. You could. I mean, Helena's gone with these slightly Among Us themed oofs and
Slightly.
snow impacts.
Slight.
You can create your own animations and you can have something hitting those instead. That'd be great fun.
Yeah. So more levels, different loose screens, anything you want.
You could record your own voice instead of my slightly crazy voice. All those oofs were me. Don't worry, no dads were harmed in the making of this game.
It's a film now.
Can you post the link to the project? Okay, do you want the link to the whole project? I can link the asset pack again. So let's get the asset pack link again. So that's the link to the asset pack.
Oh. So do you want the link to the game? The finished game.
So that's the link to the asset pack, and I suppose Lena can link the finished game if we want to.
So
do you want to find have you got the tab for the finished game?
No, I think I.
Oh, you haven't got the tab for that at the moment. Okay.
No, but
we can grab that and let me see if I've got that link.
I'm just gonna do that. So, does anyone want me to recap anything? Because I know
now's a really good time if you want us to recap over anything. There's anything you're stuck on. Yes, please. I'd like to compare your project to mine. Got you. Okay.
So,
let me just find that project.
Yeah. So, I'm. Yeah. What do I do?
Okay, I'm just going to go and find your original game to link to. You can perhaps just show again the code in the animation screens, because that's some of the slightly trickier things.
So here we go. So
I'm just finding that link now for the original. Oh, there we are. Okay.
Yeah. So another embellishment that you can do if you want to share this with your friends or just share this online is you can make a thumbnail, but that's kind of up to you.
Right, I'll just pop to that original game link back in.
Yeah, so there are a lot of embellishments that we can do.
Oh, and Ashley's also saying that link, that current link, is fine as well. Well, we can do that.
That's in the private chat.
So there we go. Game link's been stuck in there. So there we go. We can see the game links. And again, the asset pack link, if anyone wants to try from there again. I'll put that in there as well.
Yep. So,
excellent.
What should we do now? We have 10 minutes.
Well, I mean, again, now's a great time. So we've kind of gone over the main part of it. Hopefully people have got stuff working. I suppose the person who's asking the link to go, because he wanted to compare it to our project to his, perhaps he could tell us what's wrong with his project, what he appears to be stuck on, and we can try and help. So we can try and help with anything he's stuck on, and see if we can go back over any areas that aren't quite working as people want them to.
Yeah, so I'll just go over the sounds just in case anyone needs them.
Oh yeah, the forever loops of the sound. Yeah.
My mouse got so big. I can go over this too again.
Oh, the animation. Okay. I guess it's worth just saying about those hides and shows, because if you don't do the hides and shows, you start the game with everything on the screen. at the same time, which looks a bit odd.
Yeah, it might look a little bit weird. So,
oh, okay. Hold on. The project he's trying to get help for. Oh, there we go.
should I have a look?
So let me see. So he's got the animation. He's got the.
Whoops.
Appears to be good.
I'll just put it on this again.
Right. Well, I will see if I can see. Ah, okay. So what you need for this, so there's code in. If you go, Helena, to the animation 1 sprite, and there's code in each of the animation sprites that says to hide the animation sprite when we start the animation. So if I press start, it's animation to 0. So you need to make sure, and this is for, what is it now? Marcello Romani. I hope I'm saying that right. In the animation 1, there's a when, if you show animation 1, show the when flag clicked part, Helena. So you've got this in animation 1, but you also need to drag this same chunk of code into animation 2 and animation 3, so they are all hidden. So they all start hidden.
Hide at the start too, because that's this animation.
So that should hide as well. But it needs to be in animation 2 and 3. It's worth dragging that when flag clicked into those.
I'm just gonna, yeah.
Do you want to show that it's in animation 2 and 3 as well?
So we've got pretty much the same code.
So they've all got to have this at the top, just so then they don't show up on the top of anything. So that's the first issue. Oh, but you've got the animation showing straight away. I understand what's wrong here. No, okay, so you're showing the chimney hit straight away. Around the chimney slap, there should be an if touching chimney. So Helena, can you show me in the Santa sprite?
Oh,
if you zoom in on the, so yeah, if you put your mouse over if touching chimney. So in the else needs to say if touching chimney, then you set animation to chimney slam.
Yeah, and also.
So yeah, that's it. It. Yeah. So that should fix you up, Marcello Romani. Oh, he says done. Brilliant. And oh, okay. Data Strobe has also got a version, so he said you can see Private Dino.
Yeah.
Okay. Let me have a look at that. I'll see how that looks up.
Anyone wants to me to recap anything, then just tell me, because I've got 7 minutes.
Okay, and so Private Dino, yours is running, is it? Let's have a look. Didn't follow all the code. Well, that looks pretty good.
That looks like it works. Oh. Okay.
Okay, no, that's cool.
Let's have a look at what's.
Broadcast victory. Oh, okay. So what's this? Broadcast victory. Oh, and you've got Santa hit.
That was an evil laugh.
When I receive Santa hit, touching other sprites. Okay, on the chimneys. Yeah, okay.
So it already has here that if it's touching chimney top, then it will send or set animation to win. So I don't think we need the victory.
Well, he's still working on this code, I think. So that's cool. But thank you there, Data Strobe. Okay. Should it be if else, if else, if else? So yes, potentially it could be. So you could nest them all the way down.
But it's unnecessary.
It is unnecessary.
Because if the reason there's only one if else is just to make it easier. If you're a mean person, then you don't have to have the else.
So the thing about this one is when it touches the chimney top and the chimney, because those sprites are so close together, it could accidentally go through one into the other. So you need to stop the script before it picks up the other with the else, as in with if or this or else. But the other parts, the other scenery parts are far enough apart, you wouldn't normally get that double hit. You might be able to get it if you get yourself just in the corner between the snow and the floor. So there might be, you get a double hit there. So we haven't managed to make that happen. We did try. We haven't managed to make that happen yet.
Because it's pretty easy because we did the if else.
Oh, it went a bit wrong because the internet went off for 8 minutes.
Oh,
okay.
So would you want us to recap?
So I guess we can recap where we went on potentially on launching it, as in, let me see. So we did the part in Santa where we broadcast Santa hit, and we said if chimney top set animation to win. So then in the win condition, Helena, do you want to show the win condition code?
Which win condition?
On
This
win.
one.
So we got this, in the win code.
So if animation needs win, then it will show this sprite.
The win sprite, yeah.
And it will play win sound.
Okay, but that's based on checking that first it's when it receives, which is in the events section, the Santa hit, and then it checks the animation type, and if it's win, then it does the show. So that's the code you would need to get that to show there for Data Strobe. I keep wanting to say Private Dino because that's your Scratch name. Cool. So hopefully that will get you running.
Yep. Anyone else need some recapping, or are we good?
Well, we're about 3 minutes away, I think now. So hopefully people have got this running. We're going to stay. I mean, I'll stay kind of around on chat, as will Helena. So if there's any problems, we'll try and answer in chat and see if we can help out that way. I think we can. I might need to just figure out how I get into the Twitch stream as well, actually. But I'm certainly on the StreamYard and the YouTube chat. Okay. Hopefully everyone's got that working, and hopefully that's been fun.
So
I guess is that back to the studio.
Right. Well, that was a fantastic session. Thanks very much, Lena and Danny. Wow, that was such fun and beautifully presented, and some really interesting technical ideas. So thanks a lot. Now we're going on to Louis, who's joining us, hopefully in the next couple of minutes, to show you how to hack your homework in maths using the Python magic. So Louis, hi there. How are you doing?
Hi. Great. Can you hear me?
Good to see you. Good to see you.
Great.
So we're very excited about Python hacking the homework. So over to you.
Great. Can you hear me fine? Is that all good?
Yeah.
Great.
All
okay. Could we switch to my screen now? Cool. There are two links that would be great to put through chat. I think they're on the Slack. So essentially, we're going to be doing a couple of things here. So basically, the goal of this is to do some problem solving, and there's something which I kind of want to do as maybe a bit of an extension, which is it can get some of the fun, some of like the theory behind what we're going to do today as an extension is pretty advanced, but hopefully it's not going to be too complicated. But if we get the time, we're going to try and make some code that first of all does Caesar cipher, and second of all, given an encrypted Caesar cipher message, as an extension we can use frequency analysis to figure out what the original message is. So it sounds very complicated, but we'll build up to it. So the first thing to do is to go to trinket.io /Python3. Make sure you got that 3 in there. And then just get that going. To make sure it's all running, what you can do is I'm going to zoom in quickly. You can type, you can make sure that Trinket's working, type print hello world exactly like I have it with the brackets and the quotation marks, and we should see hello world if you hit the run button. So again, if you go to this URL, so trinket.io/python3, and again, hopefully this link should be in the chat. And also, yeah, great, Richard has put them in the Twitch chat. And he's also put a link to this. So this is tutorial.dewalt.uk/course/python/exercises. You know, just remember that, just need to click the 2 links. I will wait 30 seconds. Well, when everyone just gets those links loaded, it's literally just clicking the 2 links in chat and just opening them. And if you can, just make sure everything's working. Try running this. Make sure you see hello world. If anyone does not see hello world, it'd be nice to fix these issues sooner rather than later. I don't want to go too far into the session before we realize what those issues are. So can I wait 30 seconds? So hopefully what we're doing today is problem solving, right? And this is a really wide range of topics. And the general idea is that we talk about algorithms and not necessarily programming languages in particular. So even though we're going to be using Python today, what we're going to talk about here isn't dependent on Python. We're just talking about general algorithms, and we happen to be using Python to implement it. Because I haven't seen anyone saying they're having issues in chat, I think I'm good to move on. Hopefully you've seen hello world. Please let me know if you don't. Also, let me know if it's all set up. You don't have to, but that's it's also nice to see whether it's working. Although I will just assume that it's working if I'm not getting any messages in chat. Okay, so the first thing to talk about is that if you go to this link, the tutorial.dewalt link, we've got these different sections. So you can click on any of these cards and we'll open it. So you need to click on the title to open and close it. So we're going to come back to Cypher, but I think we should start off with FizzBuzz, right? This is a pretty common interview question. The idea is that if you're going to interview for a job that involves programming, they want to see how you can solve certain problems, and FizzBuzz is a classic example of this. It's just going to be like a warm up for what we're doing today. So the idea is that you need to so your program should print the numbers from 1 to 1,000. But if the number is a multiple of 3, you need to print fizz. If it's a multiple of 5, you need to print buzz. If it's a multiple of 3 and 5, you need to print fizzbuzz, like that. So it's example 4. I'm going to try to enlarge the code in Trinkets. I'm not sure why. Oh, there's some settings somewhere, isn't there? I forgot this. Cool. Hopefully that's a bit better, a bit clearer. Yeah. So this is what the first 20 lines should look like. So we see 1, 2, and then instead of printing out 3 here, 3 is obviously a multiple of 3. Hence we print out fizz, and then we go to 4, and then 4 is not a multiple of 3. It's not a multiple of 5. So just print out 4 by itself. 5 is a multiple of 5, obviously. 6 is a multiple of 3. 2 times 3. And then let's just skip a few. Let's go to 15. 15 is a multiple of 3 and 5. And so in this case, we print fizzbuzz. And so I'm going to show you a few things to get you started, but ultimately here, I want you to try and make this program yourself. And this is just a warm-up, by the way. So we're going to try and move on from here. So if this doesn't seem particularly interesting to you, don't worry. It's just a warm-up. So it's something I need to show you first of all, which is how in code can we say, is our variable n or x, let's say, is x divisible by 3, right? So we're going to have some kind of for loops. We're going to say for x in range 0, 1,000, and then we're going to do the whole fizzbuzz. If x is multiple of 3, then print print fizz, otherwise buzz or all that kind of stuff. Just for now, let's just see if our loop's working, right? So we've got our for loop, so we're saying for x in the range from 0 to 1,000, and it's not going to include 1,000. So in fact, if we want it to include 1,000, we probably want to start actually at 1. I think that's what this does. Yeah, this starts at 1, so let's start at 1 in our code as well. We could go to 1,001 because it goes up to, but not including the upper number here, and it's going to assign x each time to one of these variables. It's going to go 1, 2, 3, and each time it's going to print out that number. So we should see all the numbers from 1 to 1,000. So we see 1,000 right at the bottom. and we see 1 right at the top. Okay. So the next question is, how programmatically can we say, is this number a multiple of 3? And for that we can use the modulus operation, and I'll explain this in a second. What I'm going to do for now is I'm going to comment out this code. And anytime you put a hashtag in Python in front of some code, it just gets ignored. So it's as if there was no code there at all. And what that means is right now we're not going to. It's as if the file's empty because all this stuff's going to get ignored. It just means that I can have that code there without having to delete it, but it's not going to run. So I just want to sort of leave that aside for the time being, so we can come back to it later. The way that we can tell if a number is divisible by another number is we can use the modulus operator, right? So imagine you've done 10 divided by 6, right? If you're doing this in school, you might sometimes get taught you find how many times can 6 go into it, and then you have a remainder. Yeah. So 10 divided by 6. Well, 6 can fit into that once. So we have 1. So the result of 10 divided by 6 is 1, and there's a remainder of 4 in this case, right? So we can get 6 into 10 with a remainder of 4. Another example is 15. We can put 2 6s in there with a remainder of 3. So 15 divided by 6 is 2, remainder 3. And in Python, if you want to do 15 divided by 6, it will actually give us the decimal answer. But I think if we do this, it will give us the integer answer. So it will only give us the 2-bit if I use a double slash. Yeah. And this is where the interesting operator comes in, which is the modulus operator, which gives us the remainder of the division. So what this is saying is, what is the remainder of 15 divided by 6? Well, it should be 3, right? Because 2 times 6 is 12, plus 3 is 15. And so if you want to know whether a number is divisible by another number, you can say, well, let's say we have some kind of variable n is equal to 15 in this case. We want to see if n is divisible by 3. Well, that's just the same as saying, is the remainder of dividing one number by another, is the remainder of that 0, right? Because if we divide 12 by 6, we've got 2 6s with 0 remainder. So here we should see true. Exactly, because 15 divided by 3, the remainder of that is 0. If I put in 16 for this case, I should say false, because 16 divided by 3, the remainder of that is 1, which is not 0. And hence we will print out false. And I think with this information, you should be able to do the FizzBuzz challenge. And if you're working on this, it'd be great to give us your links to your trinket if you can. It's up to you. It's good if you're getting stuck, especially. And so yeah, so read the challenge, exactly what it. Make sure you're clear about what it says here. See because there are a few tricks here. Because at first this might seem like a very simple thing, and it isn't very complicated. But there are some clever things you can do to make it neater, and I will explain that later. Okay, so I'll do the first example. So I'll say if I'm going to get rid of this n. So it's the thing that you want is the for loop. You want the 4x in range bit here. Whoops. So I can say if x mod 3 equals 0, print this. Else print x. So this obviously isn't the final answer. This isn't correct at all, but it's going on the right track. So this is like your starting code. So see if you can figure out using this how to move on to print out the fizz and the buzz. So here we can see 1, 2, 1, 2, and instead of 3 we printed out fizz, which is correct. And it's all correct, but it goes wrong after a while. Unfortunately, Trinket seems to keep on scrolling down for me when I don't want it to. That's annoying. Yeah, and anytime I click on this, it just scrolls down. Never mind. Yeah, so here it should have printed out buzz, and here it should have printed out fizz buzz because 15 is a multiple of 3 and 5. So I'm going to give you maybe 10 minutes to try and work on that. You may get it done within that time. You probably will, actually. And when you get it done, make sure you send us, I just say it in chat or send us a link to your trinket so we can just double check that it's all working. So yeah, and if you want to make sure you're doing it right, if you get this output from your program, you're probably doing it right. If you get something that looks exactly like this for the first 20, so what you can do actually, because 1,000 is quite a lot, maybe just to go up to 20. So again, we have to say 21 because it goes up to, but not including 21. This means you just double check and cross compare between these two pages. So I'm gonna leave my my window on here for a bit. And yeah, so let me know if you have any updates. As in if you're having any trouble or if it's working, also let us know. That'd be really great. After this, we're going to be moving on to see the cipher, and yeah, some tricks to do with that. I think in a couple of minutes, I will start showing the rest of the solution. So I'll try and give out solution in parts. I'm keeping an eye on the chat to make sure that no one's having issues. Yeah, it's going to give it 2 more minutes and then I'll do the next part of the solution. And I'll give it a few more minutes after that before we move on. Get another 45 seconds, then I'll do this next part of the solution, and we'll see how it's going. All right. Okay. So again, you've got enough time. So don't worry if you're still working on it. This is the next part of the solution. Again, this is still not correct. There's still more we have to do even after this. Yes, yeah, that's a common thing when you have trying to get fizzbuzz on the same line is somewhat important. It's somewhat important to the challenge. So in my case, my one's broken in that when it should be printing fizzbuzz, it's only printing fizz. So there is more to go than what I've got here. We get another 2 minutes because there are a few ways to solve this, and some are more elegant than others. But I think it's interesting to see all of them. Okay, yes. See if you can figure out how to get fizzbuzz on the same line. If it is fizzbuzz. Yeah, somebody's put the right answer in chat. That's a very good point. So, so the issue is that I reckon that a whole bunch of you have. Actually, I'm actually not 100% sure what you guys have because what I imagine, if you're getting fizz and buzz on different lines, I imagine that's because you've got two if statements. So you've got if x mod 3 equals 0, then print fizz. If x mod 5 equals 0, then print buzz. What I'm not sure is how you guys are not printing out the number. So if it's either a multiple of 3 or 5, you don't print out the number. So maybe you guys have a variable that you set. So what you could do is you could say should print number equals false, and then if it's one of these, you say should print number equals true, or so something like that. Then you wrap this print here with if should print number. Now that's why we do it, but it's not the nicest way of doing it. Yes, somebody's just put a really good answer down, really good answer, saying you could also append what you want to print to a variable. That's a really good answer. I'm going to quickly show you one way that's just very quick from what I had before. Let's just get back to here. So what I've got here is I've got an if statement. If it's divisible by 3, print fizz. Else, if it's divisible by 5, print buzz. Else, print x. And these else's are kind of important here because if you don't have the else, then it will print too much. It will either print fizz and buzz on different lines, or it will always print the number when we don't want to. Right, but right now it's got the bug where it's not printing fizz buzz. The solution, as Jonathan said earlier, was to have an and statement. So before we do either as if statements, no worries if you're new to this. This is all about learning. So we have like an and statement here. So we can say if it's divisible by 3 and it's divisible by 5, then we print fizzbuzz. I think that looks right. So we're getting fizzbuzz. It's not separate lines. It's not. So if we talk about sort of nice solutions, it's all right. This solution here is pretty good. The one not so nice thing is the fact that we're repeating these ifs here. It'd be interesting to know if we can sort of get around that. And somebody, Jonathan again, suggested a really good idea, which was to have a variable that we append to, right? So if you're new to this, to Python and stuff, this may not make a huge amount of sense. So let's try and implement it. Let's try and implement his suggestion. Actually, I'd be interested, Jonathan, if you had done it that way, and if so, maybe you try and link it. But if not, I will start working on it on my screen. So the idea is we can have something like variable. We can call it like output, and we can initially set it to like an empty string. So these two quotes here means it's just an empty string. And we can say, I'm going to keep all this code down here, just so we have it. See it twice. I might actually comment it all out. You don't need to know this, that in Python you can use triple quotes to do a comment. So what this does is it's basically going to ignore all the stuff that's in here. Ignore this for the time being, as I was trying to do in a demonstration. So you can say if x is divisible by 3, so if the remainder of the divisor is 0, then we can say output plus equals. And what plus equals means is it means it's exactly equivalent to saying output plus and then something else. So plus equals is a shorthand. So what this does, if I say ABC, what this code here will do is it will take output and it will add on ABC to it and it will reassign it to output. And a shorthand for that is to say plus equals. Plus equals means add on to the end. And you can do it with numbers as well if you want to. In this case, we want to actually add fizz. And then we do a similar thing, but for but, and then we just print the output at the end. But there is a slight issue, and I'll show you this. We'll see it very shortly. We're not printing out the numbers here, but it is printing fizz. It's printing fizz buzz in the right place, pretty in a quite a nice way. The one thing to do is we need to say if output is just that empty string, as in because it's output's going to be the empty string if it wasn't divisible by 3 and if it wasn't divisible by 5, because if it was divisible by either of these numbers, we would have appended to the string, and hence it wouldn't be empty. But if it is empty, that means it's neither fizz nor buzz, so that can print out x. And only in the else branch we want to print out print output, and this will work as well. Cool. Right. So now hopefully, someone's got a syntax error. If you've got a syntax error, it'd be really nice if you could post a link to your code. There's a way to do this. Yeah, so if you give us the, unfortunately, if you're on YouTube, you can't send links, but if you give us the code after the Python 3, so see how it says Python 3 / and then a whole bunch of like numbers and letters. If you can give us this bit and you say, my trinket code is space, and then just write out this code, a mentor can come look at your code and see what the syntax error is. So if you hit the share button, so you hit the share button here on your trinket, right here, then go to link, and then give us this code here, and then we can try and help you figure out what's wrong. Okay, cool. So now it's time to move on to the Caesar cipher, unless anyone has any more questions from here. Okay. So, has anyone heard of Caesar cipher before? Anyone heard of it before? Let me know if you have in the chat. I know some people are still working on the previous one, so. You sure you post? So, yeah, I'm a gamer. Did you? No worries if you're behind. We're about to start something new, so it doesn't matter. If you can, post a link to your old code. Otherwise, it's not a big deal. We can move on now, so it's not too bad. If everyone else, could you go to the Python? If you go to the website and you go to Caesar cipher, maybe start reading this while we got a few people we might want to help. I don't know if anyone meant to look at the YouTube chat. if the person who's yeah, I'm a gamer, if you could post the code. Make sure you don't post a link, because if you post a link, YouTube will hide it and we can't see it. So he's going to post the code. And maybe someone look at Ken Morrison's one as well, in case of having issues. But otherwise, I'm going to sort of just read through here. So if you're still trying to fix your old version, don't worry. I'm literally just going to read out what's here so you can take a look at it in a second. Okay. So Caesar cipher is a pretty old cipher. It was first used by, as you might know, Caesar, the Roman emperor. And the idea was that he wanted to send messages to his generals, but in a way that if the messages were captured, he didn't want his enemies to know what the messages were. So this is why this is why I came up with this cipher method. So the idea is that you try to shift each letter along by a certain fixed length. So for example, if our message was ABC XYZ and the shift was 1, what that means is we need to shift each letter along one position in the alphabet. So ABC becomes BCD, because A to B, B to C, and then C to D, and then X becomes Y. X becomes Y, Y becomes Z, and then Z wraps all the way around back to A. And that's the shift was 1, but the shift could be any number, right? It could be any number between 0 and the length of the alphabet. So it could be 15, it could be 20, or it could be 2. So if that's just the number of places you shift it along, right? So for example, if the shift was 2, the message cat would become ECV, and you can convince yourself that makes sense, right? So C plus 2 is basically E. A plus 2 is C, and T plus 2 is V. So your task is to create a function called Caesar shift, and it takes in message and N, where MSG is the message, which is a string term message, and N is the number of positions the message should be shifted by. So I will get you started with this, because there's a bit to unpack here. So let's just get started with this. So there's something quite useful here, which is you want the alphabet to be imported, just so you don't have to write it all out. So this is like a nice little thing. So if you just copy this code from there, you have a variable that has every single letter in the English alphabet in the right order. Now this is going to be very useful. And let's say we want to figure out let's say we have some like letter, right? So let's call it L. Let's say that letter is let's say we're doing T for cat. We're encoding the letter T, which is part of that cat message, right? We know that it wants to go to V if we shift it along by 2. Let's say letter equals T. If we say, and don't forget this is listed right here, so don't worry if you don't quite follow what we're saying. It's printed out here. If I say alphabet.index L, what this is going to do is it's going to return the index of that letter in the alphabet. And so T, it returned 19. By the way, this is 0 index. This is sort of like an array. So in arrays in most programming languages, you start at 0, whereas we would normally start at 1. So for example, A has the position 0. But let's just get back to T quickly. So T has position 19, which is actually 20. It was actually the 20th letter, but it has index 19. So let's say we want to say index equals alphabet.index. So index is now 19. Let's say our shift is 2. We would do index plus equals 2. And then let's say we want to get the letter at a particular position. We can say alphabet and then index. So if we say alphabet 0, what this will do is it will give us the first letter, which is A. If I say 1, to give us B. But let's say I want the letter that's two positions after T. Well, that's just index, because index is position of T, and then we add 2 to it. So that should give us position 2 after it. And that gives us a V. And if you notice, V is the correct letter that we go to. There is a slight issue though, which is that currently handle what happens at Z, right? Because if we go from Z, we want to wrap around back to B if our shift amount is 2, because we go from Z to A, which is 1 shift, and then to B, which is 2 shift. So right now, if we do this, our index is going to be outside of the alphabet, and hence we try and index, when we try and access that letter, it's going to give us an error, which is an index out of range, which is exactly what we expect, right? Because we've got an alphabet, which is a fixed length, and our index is clearly beyond the end of the alphabet, and hence we're out of the range. So what we can actually do is we can come back to something that we learned about before, which is the modulus operator. And it might be at the start confusing why we would use this modulus operator, and how this would help us here. But what it does is it kind of wraps around. It's almost like a clock, right? So imagine that if you've got a 12-hour clock, we go 1, 2, 3, 4, all the way up to 11, and then we get to 12. We go back to 0. We go back to the start, right? And this is sort of what the modulus operator kind of does, if you think about it. Because if I do, let's say we're trying to do, I'm going to quickly open up a new window just to demonstrate this. So it's, I can't. Okay, I'm just going to comment out this code temporarily, so I can demonstrate what I'm talking about. Let's just print what x mod 3 is from 0 to 10. We notice it goes 0, 1, 2, and then it goes back to 0 again. And it kind of just cycles like that infinitely. So what modulus operator does is it sort of wraps around like a clock does. How a clock goes from 0 all the way to 12, way back to 0 again, and it goes out in a cycle. And that's exactly what modulus does when you think about it, because it is the remainder of division, and each time it's going to go up to the maximum number and then immediately go out to 0 again, and it's going to cycle like that infinitely. So if we say modulus the length of the alphabet, this makes sure that any integer that would go over the length of the alphabet gets wrapped back to the start. So we should see B here. So what we get, our index was 2 beyond the alphabet, but because we wrapped it around, it went back to the start. So you're definitely going to need this code in your function. So I kind of want to introduce you to a more advanced topic in a bit. So I might slightly rush along here, because it'd be really interesting if I could sort of explain to you the concept of frequency analysis, so that in your free time you could try and implement something that could automatically crack these codes. So this is how you define a function in Python, right? You say def, and then you say the function name, and then you say the arguments. And just to give you a hint, what you want to do is you want to say for L in message. And what that will do is it will give you, in each iteration of the loop, you'll get access to that letter. So if we should see, let's say I call this function. So once you define a function, you can then call it. So I can say C is a shift. Common one is by the way, this will only work if you use lowercase letters without any spaces in between them. So you can expand that, but the reason why that only works is because our alphabet only has lowercase letters. So you have to use something like that. So here our message is attack at dawn, right? So this is something that C's might want to say. Let's say we want to shift it along by 2. Right now, we haven't implemented this code. So all we're going to do is we're going to print out each letter of the message. Oh, yes, thought I spelled it wrong. Yeah, oops. So yeah, this is working. So in this for loop is where you want to implement your code. So we're going to have some kind of, let's call it output. That's just a quotation mark. And we're going to basically do this logic. Because I want to try and, we are running a slightly low on time, I want to show you something a bit more advanced. I'm going to give you a bit of time to think about this problem, and I'm going to implement it in a relatively short amount of time. I'm going to double check how long I have left, and I'm going to decide how long you're going to get. So I'm not expecting you to finish this because this is a bit advanced. Okay, I've got about 15 minutes. So I'm going to give you 5 minutes to implement this, and then I'm going to do it. So don't worry if you don't finish it in time, but just have a go. And I'm going to re-explain everything I've explained. So if you understand everything, you can just ignore me for the next couple of minutes. But at 5:30, I'm going to move on and do the solution, and I'm going to talk about how you can now crack the codes, because this is very interesting. Yeah. Okay. So just to reiterate, what we've done here is we've imported the alphabet. So this is a string containing letters A to Z. And let's say we have a letter and we want to know what the position of the letter is, we can say alphabet.index and then the letter. If our shift is a certain number, for example 2, we can add 2 to that index, and then we can say modulus the length of the alphabet, and that will wrap around the number in case it goes over the edge back to the start of the number. And with those few things, we can then, once we have the new index, the index of the new letter, we can then just say, we can then access the letter by saying alphabet and then square brackets, just like an array. And we can give in this new index, and this will give us the position of that letter. And then once we've got that letter, let's say you've done all the maths, you've done all the working out, you've done the whole Caesar stuff thing. For each letter, we want to add it to the output. So you say output plus equals, and then that letter, however you figured it out. So let's just call it new letter here. So you have to figure out this middle bit. And then at the very end, you can just return output. And what this will do is it will return the output. It will return this variable here from the function, and that means that we can say encrypted equals the response, the return of that function, and we can print out the encrypted message at the end. Okay, so I'll just give you 2 more minutes to work through that. I know it's not a huge amount of time, but just because I want us to try and move on. Just until 5:30, and I'm going to move on. And let me know if you have any trouble in the chat, and hopefully Ned's going to give you a hand. Okay, and I'm just going to run 30 seconds. Let me know if anyone's managed to get it done in the chat. I know you probably won't, because it really isn't very long. Okay, I think I'm going to try this solution now. So the idea is that we're first going to get the index of the letter. So we're going to say alphabet, oops, I can't spell, index of L, right? It's going to give us a number, like if for A would give us 0, for Z it would give us 26. And then we can add the shift amount. So we say index plus equals N, which is the shift amount here. And then I can say index equals index mod the length of the alphabet. And what I'll do is it will wrap around the index. If it goes over the length of the alphabet, wrap around back to the beginning, which is very important. And then finally, our new letter is now the letter at the position of that index. So I can say alphabet index. Okay. So cool. So now that I run it, because we return the output, we set the output to be this variable, which is called encrypted, and we print it out. And this is what we're getting. This looks pretty decent. So let's test with something else, like cat. ECV, was that correct? Was that what we thought? Yeah, so cat become ECV if the shift was 2. This seems to be working. Let's copy, so A, B, C, X, Y, Z with a shift of 1. And again, don't forget, if you've got, you can't have anything like, you can't have spaces, you can't have uppercase, you can't have like characters, because it's not in this alphabet here, because it's all lowercase ASCII letters. So let's say that the shift is 1, B, C, D, Y, Z, A. And that is exactly what we expect from here. So B, C, D, Y, Z, A. So that's exactly correct. Okay. So we don't have a huge amount of time. So I'm going to try and explain what would be a fun thing to do if you want to try and like hack these messages. So let's say you were given this message. Yes, so it says attack at dawn, but you were given this, mess of characters, right? How would you figure out what that message was? You knew it was Caesar cipher, but you don't know what the message is. You don't know what the shift amount is. So how would you figure it out? Well, it turns out that these kind of ciphers are vulnerable to an attack called frequency analysis, which is the idea that in English, here we go, let's look at this. It's a great graph from Wikipedia. So in English, on average, text follows this pattern, where E is the most common letter, then T, then A, and so on and so forth, right? So we would expect the English to look something like this, right? Imagine if you have, so let's say we have like a big long paragraph that's displaying all the orders, right? And we want to encrypt that. We would expect it to look something like this. Yeah, so it would have peaks and troughs and the same kind of areas. It wouldn't have to be exact. And in fact, it's very unlikely to ever be exact. But we can expect it to follow this kind of pattern, right? And if we were to Caesar cipher, if we were to encrypt it using a Caesar cipher and shift it along, we would expect to see this pattern shifted just by the. So let's say our shift was 2. We would expect the same peaks, but so because E would become G, we would expect to see that peak now on the letter G if it was shifted along in the encrypted text. And with that, we can figure out what the shift amount is, because we know what the graph should look like. We know that we should see roughly this. If we're instead seeing a big peak at G and another big peak at C, and same at V, that looks like it could be that peak that we saw at G looks like it could have been because of the letter E, and hence a shift of 2. Same with the peak that we maybe saw at C, maybe one we saw at V. If we see all these patterns, it seems like it could only come about because of a shift of 2. That's what we know. We now know that it's probably most likely a shift of 2. This is like a probability-based thing, so it's not 100%, but we can get quite good results. So another question is, how do we go from this information to coming up with an algorithm to actually solve this? And again, we do not have the time today to implement this, unfortunately, but it actually isn't too complicated. So what I'm going to try and do is I'm going to try and explain it in as much detail as I can in the next 5 minutes, and then hopefully you guys can go away. Maybe we'll try and work on this at home. So the first thing to do is you need to store the frequency of all the letters in some kind of variable. So temporarily, what I'm going to do is I'm going to go to Trinket. I'm going to create a. Don't worry if you don't know what this is. I'm going to create a dictionary. What a dictionary is it's like key value. So what I can say the key is A, and then I can say the value is, let's say, 0.08. Let's say. And then E, the value is like, you can find the exact values online. But the idea is you go through the alphabet and you would look up a table that said what the frequency was of each letter. And you go through and you say like, I don't know what the actual value is. Let's say like B is 0.01, all this kind of stuff. And now you could then work it out for your own. Let's say you have like a message. So you're going to say like calculate frequencies. So you're taking a message and you go through each character of that message and you would count up the occurrences of A's and the occurrences of B's and the occurrences of C's. And then once you've gone through the whole message, you would then average them out and then you would get a frequency. So let's say you found you found 10 A's and you found 2 B's and the total number of, and they have like the length of the message, right? What you could do is you can then say frequency of A was A divided by the length of the message, right? And then the frequency of B is B divided by the length of the message. Okay. And now, so let's say that you've done this for your encrypted message, right? So you've now got the frequencies for your encrypted message, and you've got the known frequencies. Yeah. What you can do now is you can then see how do they differ. So what you could do is there's only 27 possibilities for n for the Caesar shift. So what you could do is you could shift along the message by every number from 0 to 27 inclusive, and or from 0 to 27. And then you could calculate the frequencies for each one, and then you can see out of all of those shifts that you've picked. So if you pick the shift of 2, if you pick the shift of 20, if you pick the shift of 15, based on the frequency you calculate for each message, which one got closest to the well-known frequency for the English language, right? And the one final piece of the puzzle that you need to know to be able to solve this is, how do you decide whether it's close or not to the well-known frequency? Well, what you can do is you can just say I expect the frequency of A to be 0.08, and I know what I got as a frequency. Let's just say difference equals frequency A minus frequencies. So the known frequency of A. So what is the difference between each of these? And I can add up the differences for all the different letters. I can say plus frequency B minus frequencies B. And I can go through all these letters and then come up with a total difference score to see how different was it from the expected value. And then you can find the shift that gave you the lowest difference score. There is one more thing to do, which is that just doing a subtraction here, because sometimes the frequency might be a bit below, sometimes it might be a bit above. And unfortunately, if we do the subtraction here, we might get negative numbers, which means that when we're adding the differences each time, because this difference might be negative, which isn't really useful, because if we want our output variable to tell us what the difference is, we don't want it to be negative. We want like a big positive number to be very different and a very close to 0 number to be not very different. And so we can do to make this positive, we can square it. So we can do it to the power of 2. And what that means is we take all of these, which might be negative, and we square them, which makes sure that they're always positive. We then add up all those differences. We get our difference score from that, and then we can use it to calculate which one had the lowest difference score, and from that we can figure out what the likely message is. And I know that I'm sort of out of time now. So I'm going to pass that to you. Sorry about the rushed ending there. It's just something that would be an interesting project to try and work on in your free time. But I'm pretty sure I'm out of time. I don't know if Peter wants to, or someone wants to join. Pretty sure that's it. Hi, Richard.
Hi, Lee. That was really good, man. I like that.
Thanks.
That's a nice bit of encryption for a Saturday afternoon. Can't beat that.
Great.
It seems to be getting some lots of good comments in the chat as well. That's cool. Right. I'll say goodbye then, Louis. Thanks a lot.
Yeah.
See you next time.
Thank you.
Bye.
Bye.
Hi everyone, it's Richard Nozzi here again. We're going to try something a bit new today and do some machine learning with Python. So hopefully you'll have seen that you need to have a Google account for this activity today, because we're going to be using a really cool Google capability called Colab, which basically lets us run and use lots of machine learning technology without having to install it on our computer. And it also means that our programs will run a lot faster as well, because we'll be using Google servers rather than our servers. So there's only one link today, and that's the link to our an example Colab project, like a starter project, that has already some code in there to save us all some typing. So if you just go to this link, it's rpf.io/ml1. I'll just put that in the chat, and I'll even put it on the screen as well. There we go. So rpf.io/ml1, machine learning 1. So I'll just give you all a few seconds just to head over to that link. When you get there, you should see a screen like this. Hopefully that text is all big enough. I can make it a bit bigger, so if you are struggling to see that, just shout out in the chat. There's quite a lot on the screen. Don't be discouraged by what you see on the screen there. A lot of it is filled in for us, and a lot of it is helpful comments. So Ozzy said today he hasn't done much machine learning before. What is machine learning, though, Oz?
It's when a computer's given lots of images to see similarities between them, is it?
Well, so machine learning is any kind of program that can get better by itself. So normally when we write a program, we run it and it does exactly what we told it to do each time we do it. Machine learning programs are a bit different in that they can learn as they go along, and they can improve as they go along. So a really good example is teaching a computer to play a game. So for a while we've been able to have computers that play games like chess and also more complicated games like Go. But now we can use machine learning to play all sorts of games. So here's a clip here of a machine learning algorithm called AlphaStar playing StarCraft. So this is a computer playing against humans and actually beating humans quite easily as well. What you were talking about, Oz, I think about images, is one really common way of using machine learning is around image categorization and classification. So, for example, you might show it a picture of a cat, and it will tell you that it's a cat. And if you show it a picture of a dog, it will say it's a dog. The way that works is the program is shown lots of pictures of dogs and told these are dogs, and lots of pictures of cats and told these are cats. And it works out by looking at those pictures what the difference is. What do you think would happen if you showed that algorithm a picture of a cow?
It would say it was either a dog or a cat.
Right, it will just say it's either a cat or a dog. It won't know that it's a cow. So when you hear people talking about artificial intelligence and machine learning taking over the world, I don't think you have to worry too much. They can't tell the difference between a cat, a dog, and a cow. I think there were some questions in the chat about how you open that file. If you just go to that link, rpf.io/ml1, this should open for you, and this is the file. So it's a bit different from a normal program file in that you have these things here, these cells that you can click into and type. And this means that we can, rather than having to run our program all the way through every time we want to make changes to it, we can just run individual bits of it. So the first thing we need to do is take a copy of it, because this starter project it's write protected basically, so we can't change it. So if you go and click on File and then do save copy in Drive, then that will basically fork this program and give you your own copy of it that you can use. You see, I was just doing that now, and then you can see at the top it should say copy of testing vision starter. So you could change that and give it a name of your own. Machine learning, nice, right? So now you can run all these cells. Just I see you're typing cell all day. If you click on runtime and then click run all, you can see that these little swirly things happened in the corner, and that's basically running all these programs for you. Or sorry, all these cells of the program for you. And to go back to the top a second, I was there, so you can see the library we're going to be using today is called TensorFlow. And like one of the great things we know about Python is that there are lots of libraries we can use to make things simpler for us. So give me an example of a Python library we often use. Random, right? Random, the random library is really good at picking things at random for us. So we don't have to write the code to pick a random number for a list, for example. Random does it for us. Give me another example, another Python library.
GUI 0. No.
Yeah, GUI 0 is a good example. GUI 0, GPIO 0. GUI 0 we used a couple of sessions ago to make some graphical user interfaces. So someone else has written all the code that actually displays those elements on there. Another good example is the turtle library. When we use the turtle library, we don't have to write the code that moves the little turtles around on our screen. Someone's done that for us. So TensorFlow is the same thing for a machine learning algorithm. And the people at Google have written TensorFlow to make using machine learning a lot easier. There's a couple of other libraries there. We've got the OS library, which is we're just going to use to download some images for us. And we've also got Matplotlib, which is going to display those images. And finally, we've got a really powerful library called NumPy, which is a load of mathematical functions. To scroll down a little bit more, you can see there's one function that's already been written for us, the open image from URL function. And that we're going to use a bit later on when we start loading in our own images to test the algorithm. And if you have a look at the Python code there, you can see basically what it's doing is downloading an image from the web and copying it into our Google Colab. So rather than us have to type that out, it's just in the starter project for us. So I'm just going to give you 1 or 2 more minutes. If anyone's having problems getting started with Colab, just shout out in the chat and we can try and fix it. One thing I'll just show you quickly is how to share your project. So if you want us to look at it, if you can see on the top right hand side, there's the share button. If you click on that, it will open up a little window here. And then what you need to do is just go down to the bottom. You see where it says change link to Raspberry Pi Foundation in blue. Right there. Yours probably saying something different. If you click on that, click on the blue bit. Okay, click on copy link then. That's going to work. Maybe that works there. Yeah, and then click on done. You should then have the link in your clipboard to paste into the chat, for example. Well, let's just put it in the clipboard. If you paste it somewhere now, it should work. The screen's up top, is it? That's a bit annoying. That's the problem with using other people's computers. They can slow down for you. Right, let's go down to, if you scroll down to the first empty cell, we're actually going to start writing some Python programs now. First thing we're going to do is just say which machine learning model we want to use, because there are loads of actual models. Because we're going to be looking at images and trying to classify some images, we're going to use a really exciting but boringly named model called VGG16. So let's create a variable and we'll call it model, to be boring as well. And this model is preloaded for you. Now, if you can see when I was just typing there, Colab is really cool because it gives you options for auto-completing what you're typing in. So in this case, we're going for TF for TensorFlow, .keras, applications.vgg16, open brackets, close brackets. And so that's the model we're going to use today. That's a pre-trained model that's been shown lots of images and told what those are images of. In particular, it's been shown lots of images of animals. Now, the next thing we need to do is we need to create a function that's going to run our classifier. So if you go down to the next empty cell, we're going to create a new function, and we're going to call that, again, being really boring, we're going to call it classify image. It's going to classify our image for us using the TensorFlow model. And we're going to pass a parameter into this function called image URL. This function is going to load images from the web. So earlier on, we saw that we want to make the text a bit bigger. You can do that, or you can just go to view and then zoom in for the browser. That should do it. Zoom in. Oh yeah, okay, that's pretty big. Is that right? That's very big. You sure that's not too much? All right, okay. You might have some problems later. Some of our lines are quite long, but let's see how we go. So we're then going to use that function that we saw earlier that downloads an image from the web that was pre-written for us. So we'll call that get underscore image. You can see like Colab's already let you auto complete it, so you can just click rather than type, which is amazing. And we're going to pass it in that parameter, the image URL. That's going to load that into a variable called image path. And then we need to process that image so that it's in the right format for the TensorFlow library. This is like a long load of text, and often when you're doing machine learning, you find there are lots of these things that people have written for you. So in this case, we're going to run this long command here, cf.keras.preprocessing load underscore image. And you can see that Colab's really good at helping us autocomplete stuff. We're going to pass it in the image path variable, and we're going to also say what size it needs to be. So this particular model has been trained on images that are 224 pixels by 224 pixels. But you can make the text maybe a bit smaller so that whole line fits on. Yeah, there we go. Hopefully that's still readable, but then the whole line's on in one go. So, okay, we've disappeared, but that's all right. People don't want to look at us today. Fine. You can do that.
No, it wasn't.
All right, great. So now we've got that loaded and converted into the right size, we'll then show it. So then we're going to use the matplotlib library that we've imported. So we'll say plot.figure, which will create a picture for us. And we're going to show it. So that's then plot.im show and then image. Great. And that's a function that we're going to use a lot. Just to recap, we've created a function called classify image. And all it's doing right now is downloading a picture from a URL on the internet that we'll give it. It's going to do some fancy stuff to convert that into a format that our machine learning model wants to use. And then it's going to display it on the screen for us. So let's try that out. In a blank, first of all, don't forget to run that cell. So click on the little play button there. And that will run that for us. If there are any syntax errors, it will show them right there and then, which will be helpful. So we want to run classify image, not predict image. We called our function classify image. And we'll give it a picture, and we'll use this picture, which is one that you know is going to work. Now we're typing in the address for that. We've got dojo/soy, dojo.soy. So that's just a shortened link. Guess what? To a picture of
A dog.
a dog, right? So let's run that. See what happens, see if it works. Now you can see it's downloading that picture for us, and it's displayed a nice picture of a friendly-looking dog. Right, so I'm just going to pause there, let people catch up. If you want us to slow down or go over anything or show any more of the code up and down, just shout out in the chat. So now we've got a picture of a dog. We need to see what our machine learning algorithm thinks that is. Yeah. Does it know that's a dog? Maybe, because this has been trained on lots of animals, it might even be able to tell us what type of dog it is. Right, so we've got our image down. Now we actually do actually going to make the machine learning algorithm do some work for us. So we're going to go back up and edit our classify image function. So as you can see for the lines we've already typed in, we've taken our image and messed around with it so that it fits the format needed by the library. Now we're going to tell our library to actually convert that image into a bunch of numbers. Because machine learning algorithms, in fact, any computer whatsoever, they don't treat a picture as a picture, they treat it as what? A bunch of what?
A string of ones and zeros.
String ones and zeros, yeah, a bunch
Binary.
of pixels. Binary, yeah. So we're going to convert that picture file into a list of numbers for the machine learning algorithm to look at them, because that's how computers read images. So again, there are lots of functions that have been created for us. If we're using a turtle library and we're saying turtle.forward, the dot forward function in the turtle library has been made to move the turtle forward. We're just doing the same thing here. We're calling a function that does something else. So again, it's one of the TensorFlow functions. So it starts with TF. It's got Keras, which is the type of machine learning we're using, and then pre-processing. And then dot image. And here's we're doing image underscore to underscore array. What's another word for an array in programming?
List.
A what?
List.
A list, yeah. So this is basically converting that image into a list of numbers. Now we can use the NumPy library, so another library that we reported, to basically expand that out for us. This is essentially just maths that's happening in the background. I wouldn't worry too much about that last line. It's just doing some maths processing on it. Whenever you look at machine learning algorithms, you find there's lots of things that you just have to follow to make it work. Let's click on the run for that cell. Okay, Ken said the prediction function isn't working for us. Let's one of the other mentors have a look, see if they can see what's wrong. Maybe Ken, can you say how it's not working, what the error you're seeing is? Remember, at the moment, all it should be doing is just showing you showing you the picture of the dog. Right, so did you run that cell? Yeah, cool. In fact, let's just have a look at what those what that image list looks like. So let's just print it out as well as we print image. See what we've converted our image into for the algorithm to look at. And let's run that in the cell below again, run our classify image on the dog picture. So it's downloaded it. Now it's printed out that list of numbers I was talking about. That's what it's created. That's what it's changed the picture of the dog, which you can still see at the bottom, into a big bunch of numbers. And when the computer sees that, that's its way of looking at the image. And it will try and see if there are any patterns in there that help it identify the image. Let's go back up to that function. Let's just comment out that print image for the moment. Yeah. So now we're really at the last step now of using this. So we've got our image, and we're going to ask the algorithm to try and predict what it thinks it is. So we're going to create another variable, and let's call it classification result. So we're going to call the model and ask it to predict what it thinks that image is. Yeah, and we set the batch size to 1, so we're just going to run that once. Let's run that cell, see how it works. And then let's try and classify the image down the bottom there. Oh, we've got an error. Named model is not defined. Right, go back up. We obviously didn't run that cell line there, yeah, to set our model image. Oh, good, right, yeah. So now it's downloading the model for us. We've done that right at the start, shouldn't we? Right, then we've got to run classify image. Right. Well, that's done the same thing. We didn't tell it to actually print out that result. We want to print out the classification result. So it is. Classifications, typo. Again. Great, so there you go. That's brilliant. The machine learning algorithm has told us what the picture is. Yeah. The problem is I don't speak computer number language. That's no use to me at all. You need to tell it what it thinks it is in our language, right? We need to get it to tell us what actual object that was. Let's do some more code then. So let's create another variable. And so rather than, let's just call it classifications for us to read this time. So let's call it classifications this time. Again, we'll use another function from machine learning algorithm, the applications thing, and this time it's called ImageNet. It's got utilities. We want it to decode our predictions for us, and then we pass it in that bunch of numbers. What we can also do is ask it, we can tell it how many results we want to see. So in this case, we just want to see like the top, 15. Okay, so that would tell us what the top 15 numbers were, what the top 15 images were that it thinks it matched up. I'll print out classifications. Try that. And then run it. Right. And finally, we've got some human words. It thinks it's a miniature schnauzer. I'm not a huge dog expert. Do you think that is a miniature schnauzer?
I don't know.
If you look on the right though, look, it's given us some other options, a Scottish deer hound and stuff. Like that's not very nicely formatted, is it? Let's have a look at how we can maybe print that out in a bit of a nicer way. So classifications looks like it's what? What's that? String or
a list of lists.
A list of lists. So let's try and print that out in a better way. So it looks like we've got 2 square brackets at the start. So if we just print out classifications and print the first element of that list. Yeah, just run that again. Thing. Right, that's got rid of the outer list. So if we just print the first element of that inner list, the index 0 again on the outside the brackets. Yeah. So that should just print out miniature schnauzer.
No, because we want that's a 0 and 1.
Oh yeah, you're right. Good cross. What are they? Great. So now we can write a loop.
No, what?
That's right. It's just printed the top one. So now we can write a loop.
No.
So yeah, it printed out.
Yeah,
I got it. It printed out the first element, which was all the result. So what do you think those other 2 numbers mean next to it?
How certain it is that it's a miniature schnauzer?
Right, exactly. Yeah, that last number is how confident it is as a percentage. So it's 25% sure it's that sort of, it's a miniature schnauzer. It's 24. Okay, yeah, round it down. Let's see what the other options were though. So let's change our function make it a loop so that it prints all the different answers out line by line. So we say for I in range I think for I in classification, so I don't do not going to go into it. Position 0, I think we need to do that first. The list. Yeah, and then colon, and you've got below, then change classification 0, get rid of all that and just put I. Get rid of all the whole thing. Going to be I0. I think that'll work. I, 0, let's see. Right, so we want the names, don't we? So we want I1. And run your classifying again. Great, so that's better. So now we've got a nice list of all those numbers.
Tennis ball.
What?
Tennis ball.
Tennis ball. Why do you think it's? Why would it think that's a tennis ball?
It's like green grass.
Right, so it might have been shown lots of pictures of tennis balls with green grass behind it. So because this picture's got green grass in it, it thinks it's a tennis ball. Yeah. See, I'm not scared of artificial intelligent robots taking over the world. They can't tell the difference between a dog and a tennis ball. But the others are all sensible numbers, aren't they?
They're all kind of like terriers.
Terriers.
Thousands.
I do know that terriers are small dogs, so that makes sense to me. Let's just add in one more thing to our function at the top. As well as printing I1, let's print I2 as well inside the same. We do it inside the same print function. Just do a comma I2. We can see what the confidence was. Like how confident was it that that was a tennis ball?
We want it in a nice form.
Oh, this will be for now. You can use an F string if you like. Done again.
Like put it into actual percentage.
Okay, how do we do that?
Times by 100.
Right.
Unless you round it to 2 decimal places. Times by 100.
If you round it to 2 decimal places first, some of these are really small though, so I think just times it by 100 will probably work. Right. You can read them like that, I think. So 20, so you've got 25%. So it's really sure it's a miniature Schnauzer. And all the others, you're like 9% a Scottish Deerhound, 7% a Silky Terrier.
Sure
it's only 1% thought it was a tennis ball. So there's 1% chance it's a tennis ball. Someone saying my code saying I isn't defined. Any idea why? Maybe someone have a look at that, one of the other mentors. So we'll just leave that code there for a minute so people can finish off that function. And then to finish up, we'll try loading in one of our own pictures and seeing what it thinks it is. One thing you can try for your own problems is just go up and do the click on runtime and then run all to make sure it runs all the cells above as well. That's basically like, you found your problem, great. Yes, so you can go up and do if you do runtime, run all. It will run all your programs again, all the way through, without you having to run them individually. And that way you can make sure that it's done the imports and done everything else right down to the end there.
Oh, lowercase of l.
Ah. Where's L? Or L is?
Yeah, I don't know the L would be.
Right, so while we're doing that, let's find a picture to try and test it on. So let's go to Google and look for some images. What should we find? What should we look for a picture of? It looks like they've used animals. Let's try an animal first, shall we?
Snake.
Snake. All right, let's try snake. Oh, snake might be interesting. You look for a picture of Python. Nice. That's great.
Oh, I. was
I
just
thought you were
thinking
being clever.
it's
Right.
quite a common snake.
Yeah. I think we saw that the size of the pictures was 224 by 224, so we kind of want a picture of a snake that's a square picture. That would be quite good. I think it's a bit rectangular.
Yes.
I like the one a bit yawning. We can try that.
Let's just try this.
All right, let's try that one. Okay, so get that image.
Open link in
Yeah. It's not good. Not good. Got a good image. Try a different one. You just want to find one that's just got an image straight to the picture of it, rather than just being the web page.
No.
No, try a different picture. Looks like a car snake. So is that link different? No. What if you right click on the image there? That work? There we go. So grab that URL. It's quite big. And then we'll go back to our model. And instead of having the dog link, we'll put the link to our image in there. I'm going to be amazed if it gets the snake right, but it might be. Wow, nice. So that was a python. So it's a boa constrictor. I'm really impressed by that. 50% sure it was a boa constrictor.
It's not boa constrictor.
But it's got python as the third option. Thunder snake, lion snake. So what was it?
Albino reticulated python.
So it was a python, right? What did the algorithm think it was there? I'm always amazed by how clever that is then. Lots of snakes in there. A bearded gecko against the eyes and the scales. Banded gecko.
Night snake, green snake, alligator lizard. What's a sturgeon?
It's a fish, isn't it?
Chameleon.
It's all right. Let's try another one. Let's try something else. But I'm impressed that you got a snake right from that, because that's like, when I think a picture of a snake is more like a long wiggly string thing. What I think would be a snake, but that's really good. Maybe the eyes helped it. Okay, look for great white shark. A square picture of a shark. That's nice. Yeah, let's try that. This algorithm has been trained on tens of thousands of pictures of animals, though, so it might well do well.
Might even be trained on this event.
Yeah, maybe. I mean, it's a Google algorithm, so someone's got, it says classifications is not defined. Have you called your variable Lukey59? Have you called it? Scroll up a bit. I'll just have a look. Go up to the function. You see there. Have you definitely typed classifications? You haven't called it classification on this line here. I'm sure you've typed that right. Classification is one of those words where it's easy to miss out an S or put an extra I in. So just check that you called it classifications there, and that matches up. Right, let's put in that URL. Let's see how it gets on the great white shark. Hourglass. Okay, so that really got that massively wrong. What was the top?
Probably because it was all square.
Yeah, that's what I said about it. You need to find pictures that are pretty square.
Could have been a goldfinch or a table lamp.
Or an oxygen mask.
It's a lemon.
A lemon. Yeah, I mean, that's the least looking lemon I've seen.
Okay, let's do.
I think that was confused because, as you say, it squashed the picture up. So try and find a square picture. Goldfish. If you're trying images and getting good results, then please tell us what you're finding in the chat. Maybe even put in, if you're on Twitch, put in a link to the image so other people can try it out. Look for a nice square goldfish picture. But that one? That's quite square. No, to the right, that one.
It's the least square thing I've ever
That's
seen.
no, it isn't. That's pretty square.
You want them?
Square-ish. Like if it gets squashed, I don't think it'll matter too much. That's what I mean.
What happened? Where's the new window?
Yeah, I think you did. This one worked well. Someone's got. Nice. That's Danny. Nice.
Snake work.
Big old fish. Yeah, let's try that. There's no background there, so it shouldn't get any kind of tennis ball cluttering errors in there. But then again, it's on a white background, which is where you wouldn't necessarily expect like water scene. Goldfish, look at that. Snail,
And
that
look,
one.
it's just obviously that all goldfish is the same colour.
Sure, well, it's good then. But
It could have been a bow tie though.
Yeah, or an American chameleon. Or chameleons are good at disguising themselves.
Barracuda.
But the banded geckos come up again. I wonder if that's the scales in the picture. Something about the scales, does it? Well, let's find out and try it and see if it gets a banded gecko right. Probably get it wrong, but right, let's try a banded gecko. Yeah, I think it's the scales that's the similarity in the picture. There's a square banded gecko picture we can try.
It's very cute. That's square.
Yeah. And that's similar to the picture we had of the snake earlier on. So,
Yeah, because you can see like the eyes and the...
Right. This is the banded gecko website. And we're going down the rabbit hole with banded geckos. I don't know if that's going to let me do that. Pull that out of there and see.
Banded geckos are illegal.
No.
Is that eating her?
That was got a very long time. That's not a very square picture. Classification result. Let's just go back to our code for a second. And look. So is this line correct? Classification result equals model.predict image, comma, batch size equals 1. Yeah, that's.
I think is that. I don't know if this is. Oh, you put the lowercase l instead of 1.
Oh yeah, I see. Yeah.
That was the problem. You put the lowercase l.
Yes, that font isn't always good for telling between ones and L's, is it? Yeah, its batch size equals number 1 because we're just running it once.
Should find a banded gecko picture.
I think it's on the same site, isn't it? And Wikipedia is often a good source of images. Oh, that's nice. That's a nice picture. Is that a direct link? That might not work. It's not got a .jpeg at the end. You try it. I think you might not be able to download that picture. Banded gecko, 97%. It is an expert on banded geckos, this algorithm, right? I reckon, that it might have actually been trained on this picture. So it's already got that in there nailed down as a banded gecko.
And it would have gone 100%.
That's close. Okay.
I missed line 11.
Line 11.
Don't know how to look, but you can just see which.
Oh, count from the top 1, 2, 3. The spaces count to line 4, 5, 6, 7, 8, 9, 10, 11. Classification result equals model.predict.
It's in kind of this sort of area. So.
So that's really what I wanted to show today, just a simple way of using machine learning. So machine learning, one thing is it's very popular nowadays. Companies will pay lots of money for people to do clever things with machine learning. A lot of it is really about using libraries and tools that are already written out there. So hopefully today you've seen that although some of these lines of Python look quite complicated, they're just standard functions that you can call in the same way as you would call functions for the turtle library or the sensat library if you're using the sensat on there. If you enjoyed machine learning, then please let us know. In our next session, we could maybe try and do some more stuff with machine learning. Maybe actually try and build like a cats versus dogs classifier to see how we get on with doing that. We can absolutely share our code. Let's do that right now. Share that. Let's see if this works this time. I'll send it to I'll change it to anyone with the link can view this code. I'll copy the link. There we go, done. And I'll paste that in the chat right now. There we go. So that's the link you could follow. Hopefully that'll work. And we're done. I'm just going to let Peter back into our stream. Hi, Peter.
Hi there.
So I think we're all finished for the session for today, by the look of it.
Right, well, thank you very much, Richard and Ozzy, for really a fascinating session. A lot of fun seeing the banded geckos and snakes and dogs which are mistaken for tennis balls. I'll rest easier in bed because the world won't be taken over by AI bots anytime soon. And thanks, Louis, for the insight into cryptography, which was fantastic, and a wonderful game from Lena and Danny. So I hope you all had a wonderful time. And thanks for joining in. Do post any comments or email us if you've got any suggestions or requests for future sessions. We'll look at seeing if we can have another session before the end of the year in December. So don't hold back with suggestions and feedback. But thanks, everyone. And also thanks to the mentors who were in the chat. So Marcello and Jonathan and others who helped out, which was really great. So stay safe and enjoy your coding. And we'll see you again soon before long. Thanks a lot. Bye.
One thing I just wanted to mention, if you're looking for some challenges, on the 1st of December, there's a competition that starts called the Advent of Code. And every day there's a new challenge to solve in December. So it's like an advent calendar where you have to do Python challenges. If you fancy that, it's a lot of fun. There are scoreboards and leaderboards to compete on there. So have a look at Advent of Code if you want some more Python coding challenges over the Christmas period.
Brilliant. Thanks very much, Richard. So give it a go. It sounds fun. And goodbye, everyone. Bye, Ozzy and Richard. Bye. Take care.